Just a quick word or two before you think about doing this. What I'm doing here is something that probably, I don't know, maybe Tormach wouldn't recommend. One of the things that you need to watch out for, of course, is that if you've got an automatic oiler fitted to the machine, which this has, if you've got the spindle locked out, which I have for safety reasons with the spindle clamp on, there's no lubricant getting to the slides. However, for a short run that I've got 12 of these plates to make. What I have done is, in between times, started the spindle up, taken the lock off, started the spindle up, just to get the lube oil to pump into the slides and so on. I suppose you could always put some lubricant on the slides. Also, another thing to watch for is that you can't take heavy cuts. It's not designed to cut like a shaper. It hasn't got really any power to it other than the weight of the head. It's heavy enough to cut, fairly light cut. The cut I've got on at the moment is 5 thou, but that is not all the way around the form tooth. Once you start full engagement of the tooth, or full engagement of the form tool, in other words the whole front, the whole cutting edge of the form tool, it represents quite a large force required to shear off a few thousandths of an inch of metal, and that will stall the machine if you take more than, I would say, 2 thou, possibly 3 thou. Any more than that, you'll just stall it in the Z axis, and all that'll happen is that you'll have to reset the Z and then go back up and pick up where you left off. So keep the cuts low. It's an arduous process. I probably could speed it up, as I say, if I could figure out how to do a sub program or whatever, but never mind. It's served a purpose for me and it's working, so that's all that counts as far as I'm concerned. I'm making a spindle clamp for the Tormach so that I can use the spindle, lock it, use the spindle as a shaper or slotting machine. Hopefully everything will work out okay. A slight mistake with this program, but it's not that critical. I got the centre wrong. I centred everything on the centre of the hole, which I did in the lathe. But when I did the program, it's by default chosen the centre of the workpiece, and of course that's not where the centre of the hole is, because it's offset on the workpiece. So at first I couldn't figure out what was happening. I played around a bit with it and I've got it reasonably where I want it, so that'll do me. I'm doing one side first. This side is for this part of the clamp, this part of the spindle, and I'll turn it over, flip it and do the other side, which is the part that's rotating at the moment, and I'll slit it with a slitting saw and drill and tap it. You'll see it when it's finished. We are nearly at the end of this job, well, at the end of the first part of the profiling of the spindle clamp, and everything seems to have gone okay after the initial problems. As you can see, there's a little bit of, well, as I was trying to say before the battery ran out, just in the last part of the profiling, the first part of the spindle clamp, once that's done, I'll flip the part. Well, I've got to do a little bit of work. I used Fusion 360 for this. I started off using my boot camp program, but I'm out of practice with it and I just couldn't get it. The cutter was cutting on the line rather than on the edge of the cutter, so it was more or less wiping the whole of the stock out. So I had to give up on it and I reverted to Fusion 360, and this is adaptive clearing. Not the best of finishes, but I'm not bothered about the finish. This is a roughing finish. If I wanted it really smooth, I would have given it a finishing operation, but it's not necessary for this job. All the finishing's been done in here anyway. So anyway, we'll see it when we flip the part. Just a tip or two here on PathPilot or in programming in general. This is my program for the next stage of the spindle clamp, and the safe height I took directly from Pathpilot. However, you can see here one of the paths takes us directly across the middle of the work. So one of the things I did was highlighted that on the program, and I believe it's line 16110. So let's have a look. Down here somewhere. 16, 13, 14, 15, 16. There we go. Takes a bit of finding. That's that line there, but prior to that it tells it to go to a height. The height it told it to go to originally was 0.1 of an inch, 0.19, and as you can see directly in the middle of there is something that's way higher than that, probably over an inch. So in order to make things safe, I went in to the edit G-code mode and changed this line to G0Z 1.5. So that should bring it up to a safe height to clear the fixtures. It's always worth remembering that. And take a look at the paths. This is a point where it goes across the top of the work. This is, and this is. And what I've been checking here, you see that the yellow lines, I've just been tracking it around, moving the cutter around various points where I think it could interfere with the clamping arrangement across the centre, and I think we're okay here. Everything looks fine. I think this side will be okay too. So what I'll do is I'll run the program once I'm ready, and we'll see what happens. Hopefully by a little bit of careful checking you can avoid some serious crashes which I've had and which have caused problems for me in the past. So let's hope this goes okay. Well, we just started this program again. I had a slight problem in that my feeds were massively fast. Cutter dug in and broke, shifted the job on the table, so I had to reset everything. As you can see, I've started again. I've got my feeds cut right back, and I've been through the program 2 or 3 times in the edit mode just to make sure that I've got all of the passes across the middle of the work as clear of that nut that you see holding, clamping everything into the centre. Now obviously this is not a production job, it's a one-off, so I'm not worried about time. If I were, I would have gone into the program and I would have altered everything to the safe heights. I would have just put the safe height at 1.5 inches. But it was just as easy for me to stand at the machine for 10-20 minutes and actually edit the G-code at the machine. So that's what I'm doing now. The problem is, of course, there are quite a lot of commands that pass that tell the cutter to go up the top of the nut. So what I've done is I've just cut back the max velocity so that I've got reaction time. I'll be watching for it each time it comes to that part of the program where it has to lift up. Hopefully I won't get a collision, but you never know with me. Things tend to happen. So we'll see. I'll have to put the coolant on as I don't want the cutter to blind up with cuttings. So we'll see how it goes anyway. Well, things are progressing okay, a little bit slowly, but I'm not too concerned. You'll see that rather than trying to find the individual lifts between each of the 4 major parts of the work, I just found all of the Z and B changes and made them 1.5 inches like that. As you can see, it's very time wasting. Originally it would have just picked up to just clear the top of the work, but I'm not in a hurry and it serves a purpose. Basically it goes round, finishes this corner, goes a little bit here, goes into that corner, finishes, then lifts, and that's the traverse that lifts from this corner back to here is the one that goes over the top of the clamping nut. So I'll keep an eye out each time just in case I manage to miss the one, because there's rather a lot of them. But so far so good. You see it'll finish this and then go over to the next corner I'll put the camera down then because I need to be ready just in case. I wouldn't say careless, but it's so very easy to miss a single line of code and many thousands of lines of code when you're editing. You really have to be careful. It's taught me out a few times, costly cutters. I don't want it to happen this time. There you go, you see, finishing this last part. There we see the milling of the clamp is now just about finished. I've got a bit of work to do with the sledding saw, which I'll do next, but basically it doesn't look too bad at all, really. It's come out as good as I can get. Well, I could probably get a lot better, but it'll do what I want it to do. That's amazing. So here we are using some conversational programming to drill the tapping holes through the clamp. Very conservative, just taking my time with it, and that way you don't get any nasty shocks, you don't get any broken drills. Hopefully I can stop it between the net hole and get rid of some of those cuttings off the drill. I haven't got far to go on this one before it's through. That'll probably all fall off by then, so we'll see what happens. Well, that's the first hole done, and we're on to the second hole. These are through holes. I'll then counterbore them to take the heads of the tap screws. Well, I'll probably drill halfway with the clearance size drill and then open it up to take the head. Here we are, just counterboring to clearance size to halfway through the thickness of the clamp, so that when I tap the holes, I've just got a little way to tap. When I slit them, the slits will be right across the transition between the clearance hole and the tap hole, so it should be quite a neat job. I think I should have taken slightly deeper pegs. I have increased the speed somewhat, so hopefully it will not take too long. Well, we've got the spindle lock. As you can see, this clamps on the large diameter of the spindle via this pinch bolt, and the spindle itself is locked with this lower clamp, which is split across here and halfway across here, so it's independent of the top one, more or less, apart from being common metal here on this edge. So it is completely solid locked. I wouldn't like to even attempt to switch the spindle on at the moment. Now it is locked. One way I suppose you could try to see how good it is just to try and turn it by hand with a pulley, if you can get to it easily. Let's have a look. Not really, but that is absolutely solid. There's no way that's going anywhere. I cannot move it at all, so that's good. That's what I want, and we'll see when I get round to it how it works, or what its use is going to be for when I get round to finishing the tooling that I need to, or the setup for the job. I'll give you a better view of the clamp when it's off the spindle. There you can see the actual spindle part of the clamp, this smaller diameter that fits around the spindle nose, and you can see it's slit independently of the main large diameter one, apart from at the back where the screw goes through, and at this end where it's part of the parent metal, but everywhere else it's independent. So as you can see, obviously you tighten the top one up. It won't affect the bottom one too much, but you nip the bottom one up and everything locks up. So that's the idea behind it. And there you can see the slit on the left hand side, which is the side where the screw goes to tighten it up. You can see it quite clearly split there, a nice little job. It took a bit of drawing out, but didn't take that long really. Well, didn't take that much drawing out. It was just I've had very little practice of late, and I kept hitting snags, but I got there in the end.